Hello 172 class. I'm going to go through the discussion topic of where does the ambiguity come from in the law of sines and not in the law of cosines. So the way these work, when you're solving for an angle using the law of sines, what you end up with is eventually you end up with the sine of some unknown angle. Typically we use A, B, C. I'll just call it A just for purposes of having something. You either get a positive or a negative number. Okay, it's some positive or negative number. It's between 0 and 1 in absolute value, but it's positive or negative. Okay, now if it's negative, remember what happens with arcsine when we solve it. Let me just make sure you understand that when we solve this thing, we're going to end up with A equals the arcsine of that positive or negative number. Okay, so if you remember arcsine, if you end up with a positive number in going in there, it's going to say the angle is a number that lives in here. And what type of angles are those? Those are angles between 0 and pi over 2. The numbers that we get. Okay, we can't be 0, it can't be pi over 2, or we wouldn't have a triangle. But that's the type of angles that it can give us. So when we have a positive number in here, arcsine gives us a positive acute angle. All right, and that's the positive acute angle that'll give us something that is in that yellow region. But if we give it a negative sign, a negative number that is, if the work when we set up and solve ends up being a negative number, remember arcsine treats that negative output down here as it's a negative y coordinate, right? So it's the sine of some angle is a negative number. That's a negative y coordinate, so that means we're below the x-axis. Well, instead of being over here in quadrant 3, it just automatically puts it in quadrant 2, and it then also says that if that's the case, let me do this. That's a positive acute angle. But if we're down here, that's a negative acute angle. Remember, the output or the range of arcsine is negative pi over 2 to positive pi over 2. All right. So if we feed it an arcsine a negative number, it's going to say it's a negative acute angle. If we feed it a positive number, it's going to tell us a positive acute angle. All right. But what do these two things have in common? The acuteness of the angles. All right. These angles that arcsine produces are always going to be acute. Always, 100% of the time, you're going to get an acute angle. So the point is, if I set up the law of of sines, and I have this angle that I'm solving for, and let's say that it gives me what does it give me? Let's say that it gives me this side length, it gives me this side length, and it gives me this angle. So two sides in the non-included angle, that's that SSA case, right? That's the ambiguous case. And I have to solve for this angle. If I set it up and solve for it, I'm going to use these two. This is an opposite pair. And I'm going to set it up, that the sine of this angle is equal to this. So when I set it up, it's going to give me the sine of some angle. This is a positive number. This is a positive number. So it's going to say it's equal to some positive number, but it's going to tell me it's an acute angle. All right. And now, well, how does that work? Well, it's because if I went over from here, maybe this is my actual angle. This is what the arcsine is going to be of some angle. It gives me this y coordinate. But this one over here also gives me that y coordinate, and that's an obtuse angle. So there is a obtuse version of, or there's an obtuse angle that has the same y coordinate as this acute angle. And this is the one we want because it's obtuse. But arcsine is going to give us this one. okay, because it can only give me quadrant 1 and quadrant 4. It can't give me quadrant 2. It can't give me quadrant 3. It can only give me acute angles. Arcsine is designed to only produce acute angles because of its definition. Now, what about arccosine? Well, if cosine of some angle is equal to some positive or negative number, where does arccosine live? It lives in quadrant 2 and quadrant 1 and quadrant 2. So it lives in these two. And think about this. If I get a negative number, well, let's do positive first. If I get a positive number, it's going to put me here in this area. All right, those are positive x values. Remember, cosine is the x coordinate. So if it's positive, then we're going to be over here to the right side of the y-axis, and those are acute angles. All right, but if it gives me a negative number, that's going to be over here in quadrant 2. And now that we're over here, that's quadrant 2. Now that's an obtuse angle. So if there is an obtuse angle in the triangle you're solving with the law of cosines, you had these two sides, and you were solving for this angle that's included here. If you were setting this up and solving it, because this is obtuse, there would be no ambiguity at all. It would be a negative number when we set this up into the law of cosines. We'd end up with a negative number, and because we got a negative number, the angle would end up being obtuse when we did arccosine. All right, so that's where the ambiguity comes in. It comes in the fact that arcsine can only produce acute angles. So if there is an obtuse angle, arcsine can't find it. But arccosine, because of the signs of the values and the fact that we get quadrant 1 and quadrant 2 with arccosine rather than 1 and 4, which produces both acute angles. This is acute, now this is obtuse. Arccosine doesn't have any trouble finding out if there's an obtuse angle in your triangle or not. All right, so some of you had good responses, and it did come to the fact that arccosine is used when we have side, 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 or side, angle, side, meaning two sides in the included angle. So if I know how long this is, and I know how long this is, and I open them up a certain width, then that forces there's only one thing that this side length can be. All right, but it comes from the real reason there's ambiguity there is because of the use of the arctrigs to solve these triangles. And arctrig functions, arcsine, arctangent can have ambiguity because of the use of quadrant 1 and 4 and only having acute angles show up in their output.